Hi guys, Miss O'Connell here. So today we're going to be talking about part 2 of the Hooke's Law lab. If you did not complete part 1, please make sure you go back and complete that first. In part 1, your spring constant that you calculate using your graph should be in a lower magnitude. Okay, so I said this several times throughout the day yesterday and in the directions. Please make sure you do not use the data from my video. You must collect your own data. The data from my video will not correspond with the spring in the simulation. So your results will not make sense if you use those data points. You must collect your own data. If you did not collect your own data, please pause this video and go back and complete that first portion first. Okay, so to account for that, this lab will actually be due Monday morning. Okay, we're going to begin talking about part 2. Okay, so this is what the graph for part 1 looked like. We have our equation of the line. We know that if an object follows Hooke's law, the graph we see, okay, or the pattern or trend line that we see, would be a linear trend line. That linear trend line corresponds to a proportional relationship between the force and the stretch distance. And the slope of that graph, we know, is the spring constant. So yesterday during our class meet, I asked you guys to predict whether a rubber band follows Hooke's law. Please make sure you take the time to type this somewhere on your lab sheet. Predict, do you think that elastic band will stretch proportionally as force is applied? Yes or no, and why? Okay. If you intend to write a lab report as a portion of your choice board, okay, which will be an assessment, you will need to have this in if, then, because format. So I suggest that you take the time to translate that prediction into a hypothesis statement. Okay, so the actual collection of your data is going to vary. Because it's going to vary, you need to write your own procedure. Right? Each of us will have a completely different procedure based on the materials we have available in our house. If you do not have materials available in your house, we will get to that in a second. So each of us has our own separate procedure, so you need to write your own procedure. You're going to type that under part 2 in your lab sheet. Okay, this exact statement is there, part 2, elastic band system, number 8. That's the 8th step in your lab. Okay, so you're going to type your own procedure, as we all have our own procedure. Please make sure that you do not forget to go back and do that. Okay, so here are options as to how we can collect the data, how we can test whether an elastic band follows Hooke's law. So yesterday during the video, I showed you using a system of quarters. Okay, so what you can do, obviously, as demonstrated in our class period, you can enter a series of quarters into that plastic baggie that you have suspended from your elastic band. Depending on the strength of your hair tie or elastic band, you could need anywhere from 15 to 40 quarters. Okay, so I've been collecting change for years. You might not have 40 quarters. I used 8 sets of 4 quarters for a total of 32 quarters and measured the stretch distance. Okay, another way in which you can do it, I'm going to show you this video over here. You can see here that here's my medal stand for my races. I removed my medals. I attached a hair tie to one of the racks, paper clipped a clear plastic baggie to the end of the hair tie. And this video is taken at an angle, okay, so you cannot tell from the video, but I will show you with a pencil in a second. There we go. The top of that paper clip or binder clip is aligned with the 0, 0 marker on the ruler. I taped the ruler to the wall. Please ask permission via a parent, guardian, grandparent, etc. before you tape anything onto the wall. So I used a pencil to make sure that my binder clip was aligned with 0, 0. I then add 1 clementine and measure the stretch distance. Again, I use that pencil to see how long or how far the bottom of that hair tie has stretched. My first data point, I got 0.8 centimeters. I'm then going to add 2 clementines. My hair tie now stretches to 2.6 centimeters. I then add 3 clementines. It stretches to 6 centimeters. 4 clementines, I get 7.5 centimeters. 5 clementines, I got 8 centimeters. 6 clementines, I get 9 centimeters. I was afraid my hair tie was going to break, and the rest of my clementines were moldy, so I stopped there. Okay? If you cannot locate household items using Scratch, I coded a simulation. Okay, so the code to that, or the link to that simulation, is in Classroom. So if you really cannot find the materials, you can use the Scratch link and it will give you the data. Okay, once you collected the data, you're going to either need to list mass by item number. So for example, you could put 1 clementine, the stretch distance, okay, 2 clementines, the stretch distance, etc. A more accurate way to do it would be to Google the average mass of, and then the items that you use. So the average mass of a clementine is about 76 grams. Again, you want to convert to kilograms. That will be an estimation, so it won't be perfect, but we'll be able to identify the trend to determine if the elastic band follows Hooke's law. Again, if you type into Google average mass of, and then the item, the average mass will pop up. Okay, once you've collected or estimated the masses of the items you used and you've recorded the stretch distances in the lab sheet, okay, same way as we did with part 1. If you need a refresher, you can feel free to head back to that video. You're going to translate your data into the Google sheet under the elastic band system, and you're going to graph your data. Once you graph your data, you're going to again want to label your graph as a more specific graph so that you are able to determine the differences between your data tables as you paste it into your lab sheet. Okay, you also want a trend line, which was explained in the first video. To get a trend line, you go to Series, Trend Line. Okay, to add an equation of the line, under Label, you click Use Equation. Again, how well this data fits a linear trend line determines if an elastic band follows Hooke's law. Once you've collected your data, graphed your data, you're then going to answer the rest of the guiding questions. Please use data in your answers. Use data in your answers. So if it asks you, how can you describe the spring constant of both the rubber band and any springs used? Use the spring constant from your graph. If and when possible, use as much data as possible. Okay, if you have any questions, you know where to find me. I will talk to you guys tomorrow.